Hello, and welcome to ERA's webinar on root cause analysis and corrective action. I am your moderator, Christina Sanchez, the Quality Manager at ERA. Your presenter today will be David Kilhefner. David is a certified Six Sigma Black Belt with 36 years experience in continuous improvement and lean manufacturing. He obtained a Bachelor of Arts degree from Millersville University and holds numerous certifications in areas of Six Sigma, statistical process control, process variability reduction, process management, and leadership. Previous employment included senior positions in lean manufacturing and process improvement in the printing, electronics, logistics, and heavy equipment manufacturing industries. David has been with ERA for 5 years in increasingly responsible manufacturing roles and is currently the site leader for the Golden, Colorado facility. As time permits, we will address questions after the presentation. With that, I will now hand the presentation over to David.
Thank you, Christina. Again, my name is David Kilhefner. I'm the site leader here at ERA. And today's webinar is in regards to root cause analysis and corrective action. But first, we got some technical difficulties here right now. All right, there we go. So first, let me take a few minutes to talk about ERA. For those who may not be that familiar with ERA, it was founded in 1977. We're currently located in the Golden, Colorado area. In 2007, ERA was purchased by Waters Corporation. And in 2011, December of 2011, we moved into a 65,000 square foot facility. You see some pictures of our lab and our facility. We do PT, QC, CRMs, and wastewater, drinking water, soils, air and emissions, micro, radiochemistry, and custom standards. And our accreditation, you can see in the presentation slide there, what our accreditations are. So let's get to the main purpose of today's webinar, which is the root cause analysis and corrective action. Obviously, there's a lot of tools for root cause analysis, and we're only going to focus on two of those tools today, 5Y and 4M, which is also known as the Fishbone. And then we'll talk about corrective action, PDCA, which is plan, do, check, and act. So why root cause? You know, how many times have we been in situations where we've had issues or problems that have come up and we initially think we know what the solution is and we implement those solutions, only to find out that it really hasn't corrected the problem or the problem's arisen in a different area. So the whole purpose of root cause is really trying to find what is the reason for a particular problem. Typically, it's not usually something that's obvious. I've had a lot of experience where we relied on engineers or chemists to say, well, this is what we think the problem is, and we go and fix it, only to have that same issue reoccur weeks later, months later, only to find out that we have not dug deep enough to understand what the real cause of the issue is. So you implement something and you think it's worked, and only to find out that it's not worked. Root cause is something that it really takes practice, and it also takes patience. When you look at root cause, you think, well, this is pretty easy. When we talk about the 5 Ys and the 4M, it looks very easy, but it really takes a lot of practice and skill to get it done correctly. A lot of times we'll start with what we think the initial reasons are, and not go deep enough. So the secret to root cause is making sure you go deep enough. All right, we're trying to solve the actual cause. Typically, we try to solve the symptom and not the cause. So by identifying the root causes, and sometimes there's more than one root cause, we can help solve the problem. The first step, though, is to clearly understand what's the problem we're trying to address, or what's the issue that needs to be corrected. All right, so the first steps is defining that problem. What is the problem? What needs to be addressed? The other piece is try not to do it you don't want to do your root cause analysis in a vacuum. You want to make sure you have the right subject matter experts available. I also like to have somebody that's maybe not closely tied to the problem or the issue, because they can bring an outside or a different perspective and asking questions. And then you want to choose the appropriate root cause analysis tool. In some cases, the 5Y may be better. Other times, it might be the 5W1H. It could also be the Fishbone or the 4M methodology. And many times, you may end up using multiple tools to get to those root causes. So let's talk about the 5Ys. The 5Ys is no different than if you have children out there and they keep asking the question, why? Typically with 5Ys, it seems fairly simple to follow. The issue is many times we'll stop after the second why or the third why. The reason why we say at least 5 whys is typically that's how many whys it takes to get to the cause of the problem. There's other times where you may end up with 6 or 7, 8, 9, or 10 whys. And there's also a few times where you get to the third why and you might have nailed it right then and there. But the main thing is to make sure you continue to ask the whys until you cannot answer the why. Then you know you've kind of got to that problem. All right. So again, you're going to ask 5 times. You're going to look for the hidden causes, and you're going to look for the problem as an opportunity to find how to do it better. Again, it's root cause. It's to fight of the problem, to fight it and set the defect to 0. It's also to train people on how to use problem solving, how to use the 5 whys, and using a structured approach. Again, many times when we try to solve stuff, we don't use a structured approach. We attack it with tribal knowledge and those types of things. So an example here is, let's say we got a customer and we're not meeting our customer demand because our lab results are taking too long. So that first why is, why do lab results take too long? Okay, maybe in the past it's never been an issue, and as we go through this, there could be all kinds of answers to these. So trying to keep it at a high level, you're going to get stuff like that. Well, it's never been an issue before. Well, why hasn't it been an issue? Well, it's an issue now because we're not meeting that customer demand. So why aren't we meeting the customer demand? We're not managing our priorities. Okay, see the trend. You just keep asking the whys until you get to the point where that last why is, you know what? It was just accepted that we just accepted the fact that our lab results take too long. Ultimately, if we're not meeting our customer demand or our schedule, or we don't have a schedule, we want to look into that. So typically, you want to set yourself up, define your problem, make sure you get a good problem statement. What are you really trying to solve? And then start asking your whys and your questions. Typically what we would do is you pull your team together, you would have a whiteboard or a flip chart or something, and you would start writing these things out. So this next slide will actually kind of give you an idea of what you would write on your board, and you would keep going until you could not answer that last why of what was happening. You'll see in this situation where you can actually have multiple whys. Lab results are taking too long. Well, it's never been an issue before. Why is it an issue now? And you keep asking the whys. You can also say, well, hey, our lab results are taking long because we have an inefficient lab process. All right, well, why do we have inefficient lab process? And again, you keep asking the whys until you get to a problem or a possible solution to the problem. All right. Inefficient lab process, it's not organized, our flow's inadequate, we lose our samples, there's no inbox, and you can keep going from there. Again, you keep asking those questions until you get to the point of, all right, this is what we need to do. Okay, the other tool, which is actually one of my favorites, all these seem very simple, but this is one of my favorite tools to use. Sometimes the 5 whys work better. Many times the Fishbone will cover it as well. But basically the 4M model, Fishbone, Ishikawa, also it could be the 4P model. There's been many names for the Fishbone. But the 4M is really, you're looking at 4 main areas of where possible causes could be causing your issue or your problem. And that's the method. What's the method in your process? It's also the materials. It's your starting materials, your raw materials. whatever you're using, your supplier materials. It's also man, and it's also machine. All right, man is that individual person. Man is just a generic term. Could be male, female. It could be a temp, could be a chemist, could be an associate, it could be anybody. But what's that relationship? What's the possible causes that could be happening within the man? And then there's obviously the machines, which is our analytical equipment. It's any type of titrators or whatever instruments we may be using in our process would fall in those categories. So they call it a fishbone because you identify your problem, and you basically draw your lines out, and it kind of looks like the fish skeleton. Again, you would do this on a flip chart. You could do this on a whiteboard. You would draw this out, and then you'd have your subject matter experts define the problem, and you would start throwing out possible causes of why you're experiencing that problem. All right. So when we talk about manpower, some of the things that you're looking for are, are analysts working according to the standards? Are there procedures in place? Are they following the procedures? Are they even aware of the problems? Are the analysts even aware? Is there high turnover? In other words, do we have multiple people doing this same task over, and we're having high turnover? Have they been trained properly? Is there expertise at the right level that needs to be? Those are the questions. There's probably another 100 more questions you could put under manpower that you're going to start asking yourself when you have situations. When we talk about machines, tools, or equipment, and again, this is be analytical equipment or any type of tool or any type of instrument that you're using in your process. All right. Or do these, are we using the right machines for the right process? In other words, the tools and the instruments respect the process standards. Also, is the instrument capable of doing what we're asking it to do? Is the performance of the machine up to par? In other words, have we done inspections on it? Have we done PMs on it? Have we calibrated it? Those are the questions you're going to be asking. Are they working properly? Have they had breakdowns or micro stoppages recently? Obviously, one of the big clues is it producing a noise? Is it leaking something? Is something abnormally taking place with the instrument? Also, are we revising our control plans to the tools, making sure we're using the right tools with our right plans? So again, there's probably another 100 to, questions that could be answered around or asked around the machines. Materials, all right? Are our materials available according to our production requirements? In other words, do we have them when we need to have them? Are they right materials? All right. Do they meet our technical specifications? Does our stock management follow defined standards, i.e. protection, external damages from weather? Are we storing them properly? Do we have them under the right temperature conditions? Are our supplies made according to our procedures or our process? Are materials properly put near the workplace? Obviously, from a 5S lean standpoint, if we're walking and searching, that could delay and cause, example would be long analytical results time is because the materials aren't near the workspace. Are they properly identified? Is it the right code? Is it the right lot? Are the expiration dates correct? And are they working, the materials working according to supply standards? All right. With methods are, you're working with clear instructions. Are there procedures that are supposed to be followed? Whether they're work procedures or SOPs, are they understandable? Are they complete? Are they currently updated? Or is somebody using an old standard? Are processes clearly defined? Does the individual or individuals know what their role is in these processes and know what they're responsible for? Is there error-proofing methods exist? From a Japanese term, it's called poka-yoke, where you try to make sure that your processes and your methods are error-proof so that mistakes can't be made. From environmental conditions, is it the right lighting? Is it the right, cleanliness? Do we have safety issues? Is the temperature correct? And then are the operators working in a proper way? In other words, are they physically or handling their process correctly? So again, with each one of these 4 M's, you can have a multitude of questions, but this kind of gives you an understanding of what you're trying to dig for to find the possible issues or causes to your issues. So we put together kind of a scenario here where we're analyzing something and we continue to get repetitive analysis failures. In other words, we've analyzed an analyte or whatever it may be, and it's failed once. We realize it and it's failed twice. So our problem is repetitive analytical failures. All right, so if we start asking those questions that we've kind of gone through, we can look at method, machine, material, man. And the way you would typically do this with your subject matter experts is you would go around the room and you would ask those questions of what do you think a possible cause is for this repetitive failure? And you would start marking them, whether it's under machine, whether it's under method, material, man. In some cases, they could be under multiple scenarios. So if we look at the method, is there a method for this, for the analysis that needs to take place? Was it the right method? Was it the wrong method? We may not know. If we had to dilute something up beforehand, before we analyzed it, did we dilute it up properly? Again, that's the method. It was the wrong dilution. Did we set the instrument up correctly? Again, that could be set up wrong. Was our procedures, our work procedures, or SOPs, clear or unclear? Machine, was it the right instrument? Has the PMs been done on the machine? Has PMs been done on it? When was the last calibrated? Do we have the right column? Is there something leaking? Do we have the right exhaust if it's it's ICP or whatever instrument? Do we have the right exhaust coming off the instrument? From a man's standpoint, is the inexperienced analyst, is the person trained properly? Did we have different analysts do it each time, or was it the same analyst? Did the person follow instructions? Did they, or was there a rush to get it done? We're under such time pressure that we rush to get it done. And then material was it a bad product? Was it the wrong lot? Was it the wrong sample? We used the calibration and it was expired. All those questions, you can probably throw up another 100 or so of those. The thing I want to point out with the fishbone is that to me, this is, what you're looking at right now is a very high level. If you look under man, you'll see not following instructions. And down below, you'll see an arrow coming up that says did not calibrate. One of the things, and this is where you can actually start using your 5 whys to help get to the root cause, even with your 4M fishbone analysis. So, for example, why weren't they following instructions, or what did they do that they weren't following instructions? Well, they did not calibrate. All right. Then you could continue to ask the question, well, why did they not calibrate? Well, maybe it was bad training, or maybe they didn't know, or they were inexperienced, or maybe they were rushed. So you can see they're all kind of linked, but you got to continue to dig and try to identify really what that root cause is. The same with the wrong dilution. Was it the pipette? You dig. Why was it the wrong dilution? Well, maybe they piped that out, or the balance was inaccurate. A number of different things, but you have to start digging down to really understand the situation. I like the 4M. I think it's a great tool. It takes a lot of practice and digging into it and asking the right questions. Where I see many people fail with root cause is they don't go far enough. They would just draw these things out and not continue to ask. So I kind of equate the 4M, the 5Y, that you can use them synonymously, that you really need to keep asking those questions to dig down. So as you create your list, you now have this list in front of you of possible causes. The issue is it's all anecdotal. It's all tribal knowledge. You don't know for sure which one of these is the major problem. And you could end up with 3 or 4 of them. The secret is with the experience and your subject matter experts, you can start looking at and gathering facts and data to prove or disprove these causes. So again, once you've identified your possible causes, now it becomes the team's objective to gather data and facts to support these possible causes. and also it's likely that you're going to have multiple causes that need to be addressed. After you have substantiated the root cause, you need to put a plan in place to create and address those issues. So again, if I go back to my 4M method, I could come out with this of saying, okay, I have an analyst that has not been trained properly. I need to train that analyst. That could be one action. The other thing we may find out is we also have not PM'd the equipment lately, and that needs to be addressed as well. One of the things and one of the catch-alls that's out there that that people will tend to fall into is it's a human problem, it's a man problem, it's a human error type thing. And I caution everyone that if your result is that it's a human error, you need to dig further than just say it's human error. It's a number of things. Either the procedures aren't clear enough, they haven't been trained properly, they did not know, all those things. But to come back and say my root cause is the person screwed up, well, you have to dig in to figure out why that individual made a mistake, and what can we do to either educate, correct, and ensure that that mistake's not made again. But if it comes down to human error, and I always tell people here that I don't want to hear that the root cause is human error. It's something else is deeper than that. Now, with that being said, there are times when the person does know what they're supposed to be doing. They do know what the procedure are. They are experienced, and they have made an error. So you still need to ask the question, an experienced individual knows the processes and knows everything. Why did they do it wrong? It could be that they were rushed, and a lot of times that's what the answer is that individual was rushed to get it done. Well, then you need to address why that individual was rushed and look at a number of different things. So again, I do caution that, try to avoid the human error. You can identify human error, but you have to dig further into either using 5Y or using your 4M Fishbone to dig into that. Okay, so once you've kind of identified your root causes, it's important to get into the corrective action piece. All right, so you start finding those solutions to attack those issues. It's the only way you're going to remove that problem, hopefully, permanently. All right, the improvement plan describes the problem, the temporary solution, the definitive solution, and the responsibilities for implementing the plan. The new standard has to be followed by everyone. So in other words, there's training, could be new procedures, but you have to ensure that everybody understands what the new standard will be. So if we follow the PDCA methodology, which is really we need to plan, do, check, and act. And if we kind of look at this, we look at plan. So what's plan mean? It means we're identifying the problem. We're going to form our team. We're going to perform root cause analysis. We're going to gather data to support and substantiate what we think is our root cause. A lot of times, the planning piece is probably the most difficult, again, getting the root cause, because many times we don't go and substantiate the root cause. So having facts and data and not just tribal knowledge is very important. So once you have identified one or two root cause analysis or causes, you need to go and verify if that's really the situation or not. So it could be that you're doing a root cause and you're not going to immediately know, because you might have to take a week just to gather information and truly understand, is it truly a cause? Do we have data that substantiates it as a root cause? All right. Then your plan is, okay, we have identified it. We need to put a solution in place at this point in time. The do, very simple. Now we're going to initiate and implement those corrective actions. We're going to assign owners and due dates for those actions. All right, and there's going to be regular follow-up. Sometimes, you have an issue or problem that's not going to be solved overnight or within a week. Sometimes it's much bigger than that, and it may take 3 months, 3 months to 6 months, or even longer, depending if it's whether it's an IT situation, it's an instrument issue that now has to be sent out for correction. So again, it's truly understanding what the process is, what what your problem is and what are you going to do to correct it, and understanding that depending on the situation, the time may take longer. Obviously, you want to correct it as soon as possible. The check is after the designated period of time. In other words, once you've implemented your actions and your improvements and your corrections to the issue, you want to give it a certain amount of time. Now that time is going to it's going to fluctuate based on whatever the problem or the issue is. But you need to verify, did the problem or did your solution fix your problem? A lot of times, and I've seen lots of experiences where we thought we had the root cause, we've implemented a change, and we've never gone back to verify did it really fix the problem or not, only to find out that it did not fix the problem's come back, and you have to start back over again, because then you realize I didn't go deep enough, I really did not find my root cause. So you want to check, I call it trust but verify. You want to trust that the action is going to solve your problem, but you need to verify that the actions actually solved your problem, and you have to determine what that time frame is. Whether it's a 30-day, 60-day, or 90 days, we're going to go back and we're going to look to make sure that the problem has been addressed. If it has been addressed, you have the act part. The act part is if the problem hasn't reoccurred, great, you found the root cause. However, you still want to act in that, can you make other enhancements, any other improvements to the process, or any other improvements to the situation or the issue that you're trying to solve? So again, act it's just a continual circle of, even if you solved your problem, do you still want to act on that process that you're trying to fix and see if there's any more enhancements or improvements? If it did not fix your process, then you go back to square one where, okay, you get your team back together, you say, hey, we've implemented this, but we didn't truly identify the real problem. Or maybe it's just another problem that has arose. So with that said, PDCA, plan, do, check, act. All right, you're planning, you're going to plan, you're going to get the right people in the room, you're going to perform your root cause analysis, you're going to do data collection, some type of fact gathering to substantiate what you think your root causes are, you're going to identify your solutions, then you're going to implement those solutions, you're going to do the training, whatever it requires, you're going to set due dates and ownership to have those done, you're going to come back, you're going to check to validate that those actions, those improvements truly address the problem and fix the problem, and then you're going to continue to act. Either you're going to act to enhance, or you're going to act because you didn't solve the right problem. So with that, that's the end of the presentation. I went over this fairly quickly. Again, 5 Whys is a great tool. The secret to the 5 Whys is to make sure that you dig deep enough. You keep asking the 5 Whys, and you don't give up. It seems like an easy task. It's very interesting, though, that when you actually put it into practice and you have your team in front of you and you continue to ask the whys, a lot of times you're going to get silence because they've never really thought about continuing to ask those whys. But the more practice you have at it, the better you're going to get, the better your team's going to get at it, get to do that procedure. The 4 M's, a little more complicated. 4 M's is more tribal knowledge in the fact that you're looking at every possible cause and you're listing them out. You have to do a little more fact gathering, a little more data collection to verify, have you identified those root causes. Typically what I'll do is if you have a list of 50 causes or possibilities, you use your tribal knowledge and say, hey, what do you think the top 5 are possibilities? And then you go out and do your data gathering, your fact finding on those to come back and substantiate it. So with that said, that is the presentation. If there's any questions that anybody may have, please feel free to ask. We have some time left. If not, you can ask questions and we'll get back to you as soon as we possibly can. This presentation will be put out on our website for future reference if anybody wants to revisit it. To me, for spending a lot of time with lean manufacturing and process improvement, root cause is something that's easily I'm not going to say overlooked, but it's not necessarily done correctly, and it takes a lot of practice and skill. And I'm going to be honest with everyone on the presentation, the webinar, and say that I'm still not an expert at this, because I learned every time I do a new one, I learn something new as well. The secret is to be diligent and continue to ask the right questions. It's also having the facts and the data to support it. I can't tell you how many times we thought we've done the right root cause analysis only to have it backfire and create actually more problems down the road. One of the things that I always say we try to avoid is, before we make any change to a process or try to correct a problem, that we truly understand what that problem is. So if anybody has any questions, I can be reached. You can email me. We'll also try to respond as quickly as we can. I truly appreciate your time. I know we're all busy. I think this is very important, though, that people understand how to do root cause. And again, practice makes perfect. Again, I appreciate your time, and I hope people have learned from this. Also, I also look for feedback. If you found this presentation helpful, great. Let me know. If you thought it was weak in areas, let me know that as well. I'm all about process improvement. And if you have any ideas for any future webinars that we can do, from whether it's lean or process or analytical, please let us know. Again, let me see if we have any questions here. I see there is a question here.
Actually, David, we have a few questions. The first question is from Amy. She's asking, in your explanation of root cause analysis, you mentioned 5W1H a couple of times, and so she's asking if you could clarify what you mean by that.
Okay. 5W1H is really, it's a kind of a fact gathering, helping you gather facts. 5W1H is what's the issue, who did it, why, where did it happen, when did it happen, which is, in other words, was there a procedure, was there something that was a clue, and then H is how did it happen. So you go through, and so if you have a problem or an issue, you kind of go through, and usually 5W1H is isolated to, we made a wrong product. So, or we analyzed something wrong. We go through and we document our 5 W's and our 1H. And then we try to look at each one of those and say, is it where it was done was a problem? Is there anything that could happen in there? When? So that's kind of a high level of 5W1H.
Our next question is from Kevin. He was asking if we could post the presentation, and so to reiterate what you had said earlier, this presentation will be posted, and by all means, if you'd like to use this presentation as a training tool for your own groups as a starting guide for introduction to root cause analysis, you're more than welcome to. It will be available on our website in the next couple of days. Another question that we had was from Michelle. Michelle indicated that she wanted to thank you for your concise presentation. Excuse me. Under the do of PDCA, she must have, she's wondering if the individuals identified, or is it necessarily a group of people? Could it be an individual necessarily, or is it a group of people?
It's actually, it can be a group of people. It's usually up to the team and what makes the most sense. So if, it depends on what the action is. That has to be required. It can be an individual that owns it and does it, or it could be the team. That there could be multiple actions that have to take place. So from a team concept, I'm always about team, that multiple people may have ownership to certain actions. But if there's only one action that has to come out of it, it could be one owner, but the team can work on it. One way to look at it is that if I'm personally the owner of an action, I own that action, but I may have to rely on team members to get the action completed. So I hope that answers your question.
Okay. Pam is also asking a question about team size. She's asking how many people should be included in PDCA and any root cause analysis. She indicates that they have a small group of people, and they're usually involved in different analyses. So I guess kind of inferring what she might be asking is, when you have a small group, you want to have your PDCA and root cause analysis by a team. Is it appropriate to pull in people who maybe are not necessarily intimately involved in the issue to be a part of that root cause analysis team?
Yeah, I think each situation is going to be a little bit different as far as who should be on the team and how many. I think when you get it too big, it becomes a problem. Too small, you may not be getting all the right information or the right possibilities. So if you have a small group of people working, I would usually definitely have at least one subject matter expert that understands the process or understands what the problem is. I would also have, if you have a quality person involved, I would have a quality person. And then it doesn't hurt to have somebody that maybe from a different area or different department. So I would say to do a good root cause analysis, you need to have at least 3 individuals at a minimum.
And thank you, Pam. I hope I got your question right since I kind of expanded on it a little bit. The next question we have is from Kevin. Kevin's wondering how to incorporate corrective action without impacting or interrupting production.
Good question, because we all know that we have production is the number one. That's the breadwinner. That's what brings money into our companies. So the answer to that would be is you may not be able to pull everybody into a room or those individuals into a room. Ideally, that's what you want to do, but somebody may have to go out and do some legwork, and that's actually going out and talking to the individuals and maybe gathering that information while they're out doing their production. Again, I firmly believe in flexibility. One of the things I've learned over the years is if you try to follow everything by the book, you're probably going to fail, because we deal with reality every day. You guys deal with reality every day. And so trying to just grab a team and put them together may not always work. So you have to kind of think outside the box and say, okay, we really need to solve this problem, but I don't have the time or I don't have the resources to do this. So how am I going to tackle this? You can go out and you can do interviews to get the information that you may need. So again, flexibility.
Okay, our next question is from Martha. Martha, and actually, David, I'm going to answer this one if you don't mind. Martha's question is, does ERA have a QA staff separate from the technical staff? Do they take the lead on these QA issues, or are they a resource for anyone who brings a problem to light? Martha, my name is Christina Sanchez. I'm the quality manager at ERA, and we do have a staff. Depending on the situation, we may or may not take the lead. However, for root cause analysis, the member of quality will always be a member of the team. Essentially, what our goal is not only to help drive it to root cause analysis to closure. We are responsible for that verification step in PDCA. We are also responsible for assuring that any changes that we make do not have a negative impact to our or that any changes that we propose do not have a negative impact to our accreditation or our quality management system. So in the case of ERA, we do have a quality staff. We may or may not be the leaders for root cause analysis, but we are at least always a team member. We've had a couple of questions about asking for details on when the presentation will be made available online. We will send out either an email or a notification via the website on when the presentation will be available. Shane is asking, is there a preventive action process? Process would seem that this would be great when reacting to a problem, but how would we necessarily apply these same tools to something that is more a prevention piece rather than just corrective action?
Yeah, I mean, one of the things that, we use here is we call it a CAPA, and that's corrective action, preventive action. So to your point, we focus on the corrective action, and then the preventive action is sometimes the preventive action is going to be a little bit different to ensure that it doesn't happen again. Many times when you're doing corrective action, you find that, wow, we have a lot of other things that are going on here that we've uncovered, whether our procedures are wrong or, you know what, we want to implement something because we're relying on human nature to get this done. So can we take human nature out of the process? Our corrective action might be, we have to train the individual, rewrite the procedures. Again, if you go back to there was a point in the slide where we talked about error proofing. To me, that's where your preventive action comes into place. Is your error proofing. You're trying to put something in place that will definitely prevent that mistake, that error, that issue, that problem from reoccurring. The point is, at the same time, you have to correct it. If it's a major issue, you need to put something in place to correct it immediately. Preventive would be looking at, what can I do? Can I minimize some of the manual processes by automating it? Can I use my IT? Can I use our systems? Can I do something of that nature that actually helps in preventing that error? So again, right now root cause is kind of digging down into the causes. Sometimes you're going to have to put actions in place to correct it, but then preventive may be a totally different action going forward. So good question.
Our next question is from Michelle. Michelle's wondering that if training is identified as the specific corrective action for a particular individual due to that their lack of training being identified as the root cause, is it appropriate to identify the person by name in the corrective action report, and why or why not?
Oh, wow, that's a good question. I've worked for very large companies and I've worked for very small companies. And you could go either way. It all depends on the culture that you're working in. I personally feel that if it's it's an individual that needs additional training, to put them on your action plan and say this individual needs to be trained a little bit more, I'm okay with that. But again, it's a judgment call. You know your people better than I do. So each culture is going to be a little bit different. Will people take offense to that? I don't know. But at the same time, if you're documenting your corrective action and you're documenting, I feel you have to make that judgment call. You could say it's an analyst, you could say it's a chemist if you don't want to use names. But obviously you internally will know who that individual is. So I'm not giving you a direct answer, and I apologize for that, because each situation is going to be a little bit different.
Okay, Karen has a question regarding when you reopen a corrective action, do you apply the method again? And do you go back and start root cause analysis again? And if so, do you reapply the same root cause analysis tool that you used previously, or do you choose another? That's a good question. I would probably look at what we already had established, revisit that, and then make a determination, do I have to go with a different type of root cause? Maybe it's the 5W1H, maybe it's the Y. If I did a fishbone and found out that we put our actions in place and it did not solve the problem, I would not go back and recreate the whole thing. I would go back and say, what did we miss? All right, and I would probably pull out the 5 Ys at that time. If I did a 5Y, I may go back and pull out the fishbone. But again, I wouldn't start from scratch. I would go back to see what did we already have, revisit it, and see what we missed first. Okay, our next question is from David. David is asking that in the TNI ISO 17025 standards, there is a clause that states that root cause analysis must be completed for systemic errors, but not necessarily for random error. Do you have an opinion on this statistical approach?
Yeah, for systematic errors, I'm familiar with that T&I standard. For systematic, continuous errors, I definitely support that you have to do root cause. To me, that also constitutes a kappa, where if you're continually focusing on, improving that systemic error. So I definitely support that. You definitely need to have root cause analysis done for that. For the random stuff, I'll be honest with you, because we have issues and errors that happen, every day, and so do you want to try to root cause every single random error? The answer is no. First of all, we don't have the time. So typically what we'll do with our root cause here is, as we look through things, and if things continue to happen, so if we start seeing a systemic problem, or it's happened okay, this has happened 3 times over the last, month, 2 months, we may look at that and start saying, okay, we need to look into this a little further, because this is not an isolated incident. This is something that's happened more than once. So I caution to try to solve every single problem with root cause analysis if it's a systemic problem. So, for example, the examples that I used in the presentation, again, they were high level, but if I analyze something and it failed, and I reanalyzed it and it failed, that's something I'd say, okay, what was the history? Because I've probably analyzed this thing a number of times. Why did it fail this time? Twice. All right, that's telling me something changed in my process, and I need to dig into it. If the other example of our analytical time results are taking too long, to me that's a process thing that, if you accept that they're going to take that long, that's your call. But, if it's becoming an issue or problem, you want to do root cause. But I definitely support the T&I that if it's a systemic problem, it needs to be addressed, and root cause, you really need to use the tools.
Okay, our next question is from Debbie. She states that we've had repeated problems with one specific method since we updated the procedure at the end of the year. We've had several cars on it, and the problems are connected, but then we have another standard fail, and we have to initiate yet another car. At this point, I don't even know if we can say if any of the cars were effective, and they would love to see no more cars for this method. Do you have any suggestions that might be able to help them?
So, I'm assuming that you have the expertise in-house on that particular method. That's actually a very good question, because if you've had a number of cars on a number of issues, so it may be something that you may have to call in an expertise from the outside. You have to kind of look at all options on that method. Who understands that method? Do you know somebody in the industry that might be able to help you out to understand what the problem or the issue is? I'm going to, honest and say that I've been part of root cause analysis where we never really got to the root cause. You just keep digging and you keep plugging away. But sometimes, again, you have to think outside the box and say, okay, we've been dealing with this for a long time. Do I need to get an outside resource? Do I need to start looking at something else so that we understand what truly how to do this method? Again, I would approach it that way of what are we going to do differently? If I'm using root cause, we keep implementing changes and corrections, and it seems to be that we're still failing this, then it may be looking at your process itself and just digging down into each little step in the process. And when I mean not a macro level process map, but a micro, every little step, everything, you break it down to the nitty-gritty, and you try to figure out that way.
Okay, our next question is from Tracy. Tracy's question is, do you have a recommendation to make the process quick and painless for the team?
It's for root cause analysis? Yeah, quick and painless is you need somebody that actually understands root cause analysis that can lead the team through the process. It's not going to necessarily be quick, and it may not necessarily be painless, but having somebody that truly understands the process You can get through a good root cause analysis. I've seen them done in 15, 20 minutes, and I've seen them done in 2-3 days. Again, that's part of the problem with root cause analysis, is that you have to do it to gain the experience and the skill. And once you start getting to that point, you can start making them fairly quick. I'm not necessarily going to say painless, but you can get much better at it. And as your team gets involved in it, they start understanding it more, and they start, as coming together, and people start understanding it much better. So hopefully it becomes, I'm not always going to say it's going to be quick and painless, but it becomes easier.
Okay, Jonathan has made actually a really good suggestion, and he's asked that we re-display the last slide of the presentation, which shows the contact information.
Will do. Okay.
And the next question from Michael. I understand that not all of my questions are being heard, so I'm trying to speak as closely into the microphone as possible. The question from Michael is, from a QA perspective, the root cause analysis corrective action system is used for discrepancies found within processes, but management uses it as a discipline to discipline employees on repeat discrepancies. How do you help drive management to an understanding that root cause analysis is not a system for disciplinary action, but a tool used to drive process improvement?
Good question, and this kind of ties back to the human error aspect. Root cause, how do you get management to understand that is, if you provide management with the right root cause, and if it comes back that an individual's had repeated issues, you have to look at how you're dealing with that individual. It should not be, first of all, it should not be punitive to that individual. We have to look at, why is that individual having repeated issues? Is it training? One thing to think about from a management aspect is that, when you look at individuals, they may have the skill set, they may not have the skill set, and that's what's got to be determined. Do they have the right skill set? You can train them, you can get them to do it, you can stand beside them, watch them do it, and they do it right, and as soon as you walk away, they do it wrong, or something happens. So that's telling me that the person may not have the right skill set or the mentality to perform that particular function. Now, should management be punitive to that individual? No. So I would approach management with the fact that it should not be punitive. What it means is we have to find out why the individual is failing and work to get that individual to succeed. And that's a tough one with management, because I've seen it in action, and you just have to push back and say, look, we've dug into this. It's repetitive because of these issues here. It's not the individual. It's either our process, it's either our training program, a number of different things, and that's what we have to work on.
Okay, our next question is from Kevin. How do you perform the check part of the PDCA process? And how does it involve, how do you address that when the issue involved a blind sample, or if the process does not necessarily generate a numeric result? And I'm being pointed at, so I'm guessing that since this is more of a quality question, I'm going to be the one that's asked to respond to this. So generally one of the things that we will do to approach verification in the PDCA process of our root cause analysis is we could do a simple audit if it's a change to results in a change to a process. What we'll do is we'll go out and we'll re-audit that process and determine, do we see examples of continued failure? We could do some data analysis. We could collect some data and look to see if we're still seeing the same issue occurring after the implementation of the changes. It could be as simple as, are we continuing to get complaints? So there are a lot of times where we have changes that result in a change to a process that doesn't have a numerical result, and so we have to look at how else can we approach, what other tools can we use to look at how effectively that change addressed the original issue. If it meant that it was a change into the efficiency of a process, or if it reduces customer complaints or the negative impact to a customer, we can still look for those things without having to look for a specific numerical improvement. So I think that what we do is we have a tendency to approach it as another audit, and we'll audit the process that was changed and see if we continue to have audit findings that were seen at the initiation of the problem. If we do, then the change that we made, it clearly wasn't effective to eliminate the cause, and maybe we have to rethink not necessarily a root cause analysis, but what our corrections were for that root cause.
On that same note, one of the things from that check piece that, because we deal not necessarily numerically with issues, part of it is with your root cause, you want to be gathering data and you want to be gathering facts to support that cause. So once you've gathered that data, you've kind of either established what I would call a baseline type metric or a baseline type fact, and then when you do your check, you may continue to monitor whatever that baseline is to see, have you sustained, have you improved, have you eliminated going forward. I can think of a situation here where we're having an issue with water, or DI water. And, one of the things that we were trying to do is make sure we were below a certain TOC. And it was right after we moved into the building, so a whole new system, and our TOC was higher than what we like it. So we implemented a number of changes, did some root cause analysis on it, and we made some corrections, and we monitored it for, Christina, what, like 3 months to 6 months. We monitored our TOC every day, and we never had the issue again, and we actually maintained, a very good TOC level. And to this day, we still monitor it and check it every day to make sure that we haven't progressed. So again, from that situation was we made our corrections, but then we put in place a check to ensure that we have not seen a problem since.
So our next question is from Tracy. Tracy's question is, by analytical experience, is it more effective to conduct RCA in multiple brief meetings, which is more convenient obviously for the team, or is it better to set aside a large block of time to really attack the issue, so to speak, and try to drive that closure to root cause analysis in one fell swoop?
My recommendation would be, again, it's going to be situational. It depends on what the issue is and what you're trying to solve. I think starting off, if you're really, if you're not familiar, I'm sure everybody has done their root cause analysis, so this shouldn't be anything new. But if you're not comfortable with it, and your team is not comfortable with it, my recommendation would be schedule small amounts of time to initially attack it. Because what will happen is if you keep people longer than an hour, you're going to start losing focus. Also, if it's something new to the team or something that's going to be brand new, you probably want to keep it short. I would say at least 20 minutes. Get people to start thinking about what tool you're using and start thinking about it. And then I call them back and have them I would say do some mental homework on, we're going to use Fishbone, we're going to do 5 whys, here's what it is, here's our problem. You can start it off and then pull them back, give them a day, 2 days to think about it, and pull them back into the room and do it in small increments. So again, it depends on the situation. It also depends on the experience level of the team on doing root cause analysis.